Okay, we are doing section 8.2. The section 8.1 was exponent properties involving products. 8.2 is exponent properties involving quotients. So quotient is obviously when you divide two numbers. So we're going to learn what the properties are for exponents. If we divide powers that have the same base, we subtract the exponents. So if we have a to the m divided by a to the n, remembering that they have the same base, then you subtract the exponents, a to the m minus n. So an example with numbers, if we have 4 to the 7th over 4 squared, recognizing that they have the same base, then I can subtract the exponent, 7 minus 2, to 4 to the 5th. Okay, so here's some examples. If I have 8 to the 10th divided by 8 to the 4th, I subtract the exponents, turns into 8 to the 6th. On B, negative 3 to the 9th divided by negative 3 to the 3rd, I can subtract the exponents, keeping in mind that I have to have my negative 3 in parentheses, to the 6th. Okay, C, we are actually combining some of the properties that we learned in section 1. We have to combine the two on top first. So because they're being multiplied, we add the exponents on top, divided by 5 to the 7th, and now we can use the new property we just learned by subtracting those two exponents, and we get 5 to the 5th. D, before we can subtract or divide, we have to combine them into one fraction. So if we recognize that x to the 6th is over 1, then we can multiply straight across, and we get x to the 6th over x to the 4th, and now we can subtract the exponents to get x squared. E, the same thing, we have to combine them on top first. So that would be 9 to the 7th over 9 squared, which is 9 to the 5th. And F is similar to D, where we have to combine them into one fraction first, y to the 8th over y to the 5th, and then we can subtract y to the 3rd. Okay, now we have the power of a quotient. So if we are dividing, so we have a quotient, and we are raising that whole thing to an exponent, it's very similar to the power of a product. We just distribute that exponent into every term inside, even the one on the bottom. So an example with numbers, if I have 3 divided by 2, whole thing raised to the 7th power, that's 3 to the 7th over 2 to the 7th. So let's do some examples. A is just x to the 3rd over y to the 3rd. I'm just distributing that cube. On B, that negative needs to go somewhere. I would always include it with the top term. So that would be negative 7 over x quantity squared. So on top is negative 7 squared over x squared. And similar to section 1, we can combine that number. So we can simplify that a little bit more. 49 over x squared. Okay. So on A, we have two terms on top, 4 and the x squared. Keep in mind that that square does not go with the 4, it only goes with the x because there are no parentheses. If it was 4x, that whole thing to the squared, then we would have to distribute, but there is no parentheses around the 4x, so we only distribute the 3 to everything. 4 cubed x to the 6th over 5 cubed y to the 3rd. And we can combine those numbers, figure out what those are, since they're not that big. 64 x to the 6th over 125 y to the 3rd. B down below, we need to distribute that 5. A to the 10th over b to the 5th times 1 over 2a squared, and we can get that into one fraction to simplify it. So a to the 10th is all that's on top, and on the bottom we have 2a squared b to the 5th. And now we can use our property to subtract exponents. A to the 8th over 2b to the 5th is our answer. Okay, here's a couple more practice problems. If we square the a and square the b, our answer is just a squared over b squared. On b, we have to square all three terms. So it's x to the 4th over 4 squared y squared. And that 4 squared is simple enough that we can simplify it to 16. C, we have to distribute before we multiply, so we cube everything inside that first one. 2 cubed, s cubed, over 3 cubed, t cubed, times t to the 5th over 16. We can combine everything. 2 cubed is 8, s to the 3rd, t to the 5th, over 3 to the 3rd is 27, times 16 t to the 3rd. So we can simplify the constants and the t's. So if we simplify 8 over 27 times 16, the 8 cancels with the 16 to make it a 2, and the t's can also simplify. So on top we have s to the 3rd, t to the 2nd over 54. All the t's on the bottom go away. Okay, our real world problem, we have order of magnitude for the sun is 10 to the 26th, and Canopus is 10 to the 30th. How many times more luminous is Canopus than the sun? So we need to divide our luminosities. If we put Canopus on top, so 10 to the 30th divided by 10 to the 26th, we subtract the exponents to 10 to the 4th times more luminous. And again, you could figure out what that is. If it's 10 to the 4th, that means there's 4 zeros. So it's 10,000 times more luminous, or just 10 to the 4th. And that was it for section 2.